Mathematicians, we've been spending a long time mastering rounding, and the reason why we learn rounding is because it can help us check our work and determine if our exact answers actually make sense. So let's say you're presented with this problem, 534 plus 287. First, we can go ahead and add those two numbers together using the standard algorithm. So we would put our numbers on top of each other, making sure to line up all of our place values, and then we would go through and add, carrying when necessary. So 7 plus 4 is 11, so I carry my 1, and then 8 plus 3 is 11, plus the 1 that I carried would give me 12, carry my 1, and then I have 5 plus 2 is 7, plus the 1 I carried is 8. So I just solved, and my exact answer is 821. But I need to know, is my answer reasonable? Does my answer make sense? And I can do that by estimating. So we can round our numbers to their largest place values. So the largest place value here is the hundreds place. 534 rounded to its largest place value is 500. And the 287 rounded to its largest place value is 300. So now I rounded the two numbers to make an estimate. 500 plus 300 is 800. I can look at my estimate and my exact answer, and I see that they are very close together. 800 and 821 are very close together. So since my estimate and my exact answer are pretty close together, then I know that my answer is reasonable. Your answer is reasonable when it makes sense. So my answer is probably correct. 534 plus 287 equals 821. Let's try using this strategy using a different operation. So here is a subtraction problem, and my numbers go up to the thousands place. So again, I'm going to go ahead and find my exact answer by following the instructions and subtract. So here I have 3,972 minus 658. So first I'm going to go through and subtract these two numbers. I need to do some borrowing here. 12 minus 8 is 4. 6 minus 5 is 1. 9 minus 6 is 3. And 3 minus nothing is 3. So my initial thought is that my answer is 3,314, but I'm going to go ahead and use estimation to check that my answer is reasonable. So first I'm going to take my two numbers and round them to their greatest place value. My first number goes up to the thousands place. 3,972, the thousand that's closest to is 4,000. My second number is 658. And the thousand that is closest to, I'm sorry, not the thousand, the hundred that is closest to is 700. Now I'm going to subtract these two numbers to see if my answer is reasonable. I need to do some borrowing here. 10 minus 7 is 3, and 3 minus nothing is 3. I can look again at my two answers, and I can see that my exact answer and my estimate, again, are very close together. So I know that my answer is reasonable. So the answer is 3,314. This strategy is really helpful because if you get an estimate that doesn't make sense, that is not close to your exact answer, then that tells you that your answer is not reasonable and that you should go back and try again. Let's do one final example with numbers that go up to the 10,000s place. So I'm being asked to add two numbers together. I will first go ahead and find my exact answer and add both those numbers together. I will line everything up very carefully. And now I'm going to go from the ones place and add 8 plus 5, 8, 9, 10, 11, 12, 13. 7 plus 2 is 9, plus 1 more is 10. Carry that 1. 9 plus 1 is 10, carry the 1. 7 plus 2 is 9, plus 1 more is 10. Got a lot of 10s in here. And then 4 plus 2 is 6, plus 1 more is 7. So I got that my answer is 70,003. Is my answer reasonable? Could it be possible that I made a mistake? Let's find an estimate to confirm that my answer is reasonable. So I first need to round my numbers. Both my numbers go to the 10,000s place, so I'll be rounding to the nearest 10,000. For 42,975, the closest thousand is 40,000. For 27,028, the closest thousand would round up to 30,000. Then I would go through and add this, and it's 70,000. Wow, look how close my two answers are. 70,003 and 7,000. So for sure, since those answers are so close, I can say yes, that my answer is reasonable. I can be confident that the correct answer is 70,003.